Hi everybody, I'm Henry from Excellent Analytics. This video is about implementation of Mean Absolute Deviation or MAD to measure the forecast against the actual order's accuracy. This example can be applied in manufacturing, supply chain, product sales report, or alike. Our objective here is to apply the MAD in Power BI with the use of DAX calculation, such as this, in order to calculate the multi-level category of products or items with double reference of running dates accurately. Because DAX calculation is important to successfully implement this MAD into the real-world application, we will focus on this matter in this video. The DAX function involved are dates in period, average X, dates and PD, lookup value, summarize, selected value, sum X, calculate, and filter operations, and lastly, the ABS or absolute. Regarding on how this visualization was made, it will be dealt scantily here in this video. So probably I might create a separate video to detail this making of visualization in the future. Anyway, good visualization is depending on you because you know best for your audience. You can make better visualization than this depending on your target of audience. So before we proceed, let's understand the MAD in a very short elaboration or example as shown here to show the advantages. Okay, let's have a quick understanding of mean absolute deviation and its importance in forecast accuracy or key performance indicator. I have a single product here with having a order quantity in a running date and also forecast quantity. The formula of MAD is as simple as the absolute difference of the actual quantity and forecast quantity divided by the number of data points with the N or number of months depending on you. There are other forecast accuracy measurement out there, which is the MAPE, mean absolute percent error, which is basically the same as the MAD. You just remove this and it's become a mean absolute percent error. I just covered it so that it's not confused. So the MAPE is just you divide the difference by the actual quantity. Then others are mean absolute error and mean square error. As you can see, the absolute difference of this order quantity minus this forecast quantity is arranged in this manner. See, ABS, absolute of order quantity and forecast quantity, then I just drag it like that. Then the overall MAD is as simple as the average of this absolute difference. Then I just drag it because this is overall MAD in this coverage dates or months. That's why the overall MAD is the same across the all the months. The rolling MAD is as simple as this that I made this rolling MAD in a 6 months coverage only, which is 1 to 6. So while the calculation progress, it calculates the MAD backward, 6 months coverage. Of course, reason why this one 2 months because no data beyond 3 months or 2 months. So let's move on to further understand this mean absolute deviation. Here I prepared the 8-month period time of order and forecast quantity with a difference of always 1 unit, or can be negative variance and positive variance. Positive variance can be translated into excess inventory, when the negative variance can be a shortage in delivery. So the overall MAD result is 1 unit as well. So taking a closer look on this variance bar chart I prepared came from here is that you've noticed that the positive variance is more likely to happen than the negative variance, and the result of MAD is still 1 unit. So here we can say that the MAD is considering the average deviation on both sides of the forecast against actual quantity. This can be translated into the excess inventory is equally important to the shortage delivery. Anyway, If ever the shortage delivery or shortage inventory is more important than the excess inventory, then don't worry, we have a solution on how to separate them later on Power BI. So let's say if I increase the gap of order and forecast quantity into 2, let's see what happens to the overall MAD. So let's say if we increase the difference between the order and forecast to 2 units and see what happened to this overall MAD. Let's say, let's put it 6, then 2, 11, then 8. The MAD is slowly increasing into a 2 unit. Then another example is, let's say we double the order quantity and we increase the forecast quantity as well in such a way their difference is also 2 units. See what happens. Of course, the overall maybe will result the same, 2 units. So here we can draw a conclusion that the MAD is not biased at any level of quantity of actual orders. Therefore, MAD is good for quick assessment and comparison of the value of error of item by item or over period of time on very actual quantity scenario. So note, the lower the MAD, the more accurate the forecast. Another example here is that I intentionally made the difference of order to a forecast into a -1 across this 8-month period time, and you notice that the overall MAD still remains 1 unit. So lastly, the example below here is to further understand the total variance at the end of the day. What I did is I sum up these difference of order to forecast and they result to unit. Then you have a unit price of this particular item worth $100 each. Then you wanted to get the worth of your excess inventory, then you just multiply it into 2 units and the result $200. So this is the other usefulness of the summing up the total variance. Okay, let's start to set up our Power BI to calculate the mean absolute deviation and visualize it to these available prepared visuals in this canvas, such as a matrix visual, stock column chart, waterfall chart, and some slicers here. Our raw data consists of 2 tables, which is a fact data forecast versus actual table, the MAD limit, while these all MAD formulas or matrix are just empty tables that we're going to use to keep and organize our DAX formulas here. So later on this MAD rolling will be explained later the use and importance of this table. So before we start coding, we need to familiarize our raw data from this fact data forecast versus actual table. Has a stock keeping unit number, item description, actual date, forecast quantity, order quantity, market, date forecast. So this date forecast is a date where particular product was forecast reviewed in advance. So sometimes you might face this kind of raw data having a 2 set of dates, or sometimes you don't. Then next is product group and unit price. While this MAD limit is as simple as setting up our MAD limit just in case you want to control and have some KPI to measure your goals and see how they perform and see which product that needs to be controlled. So let's prepare our table by adding some calendar for the actual date and the forecast date. So we need to make a separate table that is dynamically linked to these 2 dates so that your Power BI will run efficiently. So let's add a new table. So let's call this main date or date main, and calendar is asking for start date, which is the mean X. We need to refer from the table at the forecast versus actual. Then the expression is as simple as this date actual. Okay, let's organize this a bit. Then the end date is the max date for same table, then FD same date actual. There we go. Okay, let's format this in a simple format. Use this. Okay, since our mean absolute deviation will be calculated in a monthly basis, so we need to aggregate each date into first day of the month. So we need to add a column which is meant for start of the month, and let's call it start of the month. Then let's call it, then the function is just simple as this. Then should refer this date. There you are. Date table, then the column name. Okay, so later on we will format this into a shorter text. So going forward, we need to create additional table for this date forecast so that our Power BI will run efficiently. Okay, let's call this date forecast, then the function calendar, start date, mean X, then of course FD, and the column name is this date forecast, and the max date is FD, and FD forecast 2. Then enter. Okay, let's simplify this. It's shorter. Month, day, year. Then also we need to add column start of the month. Let's make it simple as shorter as this. Let's call it like that. Then start of the month, date forecast, date. Okay, enter. Okay, now we're going to format this, connect and format this into this table. Going to this model, so we need to drag this date main and date forecast near to this our main source of data, which is the fact data forecast and actual. Then link this date main into this date actual, and this connect this date forecast to date forecast. Okay, now let's format this start of the month. Going here to this date time format, we need to go to custom. Then under this general date, let's shorten the month into 3 letters, then separate the year and month by single apostrophe like that, then year. So the example shown here should reflect what should be here. Later on we'll show it. Similarly, we need to do the same. Then general date, 3 letters, then this, then okay. Now going back to this data table, you see now the month is 3 letters and 2 numbers. So actually this is not text, it's still the format, or the data type is still date and time. So it means our DAX will still read this as date. So going to this report, let's start to populate this initial visual, which is the matrix visual, from this fact data forecast versus actual. So let's bring down the market first into this rows field, then this product group. Under the market, you can also add the item description. For the meantime, let's simplify product group only. Then the column, we need to use this main date. Here's the main date. Here it is. And go into this column. So let's deactivate the date hierarchy. Use this start of the month instead. Okay, should be like this. Then let's expand the row and should return like this. Let's initially fill in this matrix here using this initial summation of order quantity. This is actually columnar data. Then let's put it into these values. Okay, here it is. Okay. Our data is a bit cluttered when the data of the product group were all here, so we need to focus on one product group only. Let's select product group 29. So going to this slicer, we need to bring down this product group under this field. Then let's filter in this product group 29. Also the date, we need to start to filter the date. So let's start on this main date, drag this date into this slicer, then the date forecast into this second slicer. Okay, now we're able to reduce the size of the date. Okay, so next, the best way to approach this kind of data set having two dates is that we need to use a Cartesian plane, which is they are arranged in the x and y manner. So we have already a x-axis, which is the main date, and the y-axis should be the date forecast under this product group. Okay, here you go. So let's focus on local market only. And here you go. Now let's continue to bring down this forecast or forecast quantity right after the order quantity. So we need to arrange this order quantity and forecast quantity into the rows arrangement by using this format, then go to this value, then activate this show on rows. There we go. Order quantity, forecast quantity is showing on the rows. Okay, then next is I forgot to deactivate the date hierarchy. We need to use the start month of the forecast. Then let's expand. Okay, now we are beginning to see the relationship of the main date and the date of forecast. So as you can see, it is showing like this. So let's put some color background here so that we know how they behave later on. So, okay, next is to get the absolute difference between this order and forecast quantity. As I have shown earlier to the Excel file, this is the absolute difference of the order and forecast quantity. So to do that, we need to add a measure, new measure, and let's call our first measure ABS, absolute difference. Okay, then absolute. Okay, it's so the first parameter it looks is the number, so we cannot use directly the order quantity here. So the best way to do this is we need to convert this sum of quantity of order and forecast into measure. Let's begin by adding add measure to sum up the order and the forecast quantity of this matrix. So let's name it the same name as forecast quantity. Then let's say sum. Okay, so it looks the column name. So this is the time that we may able to use this order quantity. There you are. Then the forecast quantity is here, same. Okay, here is forecast quantity. Okay, let's change this to capital Q. Then let's add a measure of absolute difference, ABS difference, and order quantity minus forecast quantity. Now let's put this absolute difference into this matrix visual right after the forecast quantity. So let's remove the decimal, simplify, just make it whole number. Okay, now these are the difference. Okay, our setup is a bit complex than as expected. Okay, so since we have a separate measurement on order and forecast quantity, we now able to remove this field under these values, and we can use our measurement we did earlier, forecast quantity and the order quantity. So before we analyze the contents of the number here, we need to do some color coding or background color so that's easier to visualize. So let's put it gray, diverging, yep, same as here under the forecast quantity, and this one diverging. Okay, so let's take a closer look on our numbers. So as you notice that the diagonal formation starts from this month of February 2020 because our data that the forecast review was started actually in this particular month, February 2020. So what we're after is this number of month that it was showing here. So we need to disregard this number, because if we will not disregard them, they will just add up. If I'm going to collapse this or drill up to the product group, as you notice, the forecast quantity has increased while the order quantity remain as is. You notice 65, 20, 49, March 65, 20, 49. Because they have only a single value. This forecast has a multiple forecast quantity. when in real world situation, the forecast is being reviewed every month. So this is what happened. The forecast is reviewed every month because and expect some changes on the forecast quantity. Okay, let's create a new measurement. Our objective is to retain this forecast quantity located in a diagonal fashion just below the every order quantity, because this forecast quantity are the latest one. For example, during that month of March 2020, when this particular product was forecast on the following next month of April 2020, the quantity is 67. Then when the month of April is reached, it was revised from 67 to 86. So that's why these are the latest forecast quantity. Then we need to get rid of these following numbers so that to avoid them being summed up when this matrix is collapsed toward the product group or hiding the month of forecast review. So let's carry on. So add a new measure. So first thing to do is to retain these forecast quantities 61, 86, and so on. Okay, let's call it forecast 1 quantity. Then let's use the method of var and return so that we can break down the formula properly. Then let's call this first term forecast quantity 1. Need to use the calculate function because we were going to use filter parameter. Okay. On this expression, we can either use straight away the forecast quantity or we can redo the coding of sum, then the forecast versus actual table and forecast quantity. Yeah. So we will do this so that to minimize confusion, so that we can understand the coding better. Then the filter. Let's use filter function, and the table is that we need to use the table of date forecast, this start of the month. Okay, so date forecast table. Okay. Then the filter expression is, since this is the date forecast, then we need to use this date forecast start of the month. Okay, because it won't allow you to use other table because the first table that being called upon here is the date forecast. So that's why we need to use the date forecast month, because this is our what we are after anyway. So for every month that is equal to this date main or main date, then it should return the value whenever this matrix being collapsed. So we cannot use directly the date column because the DAX won't allow us. So we need to use the selected value, because on this right hand side of filter there should be only one value that being equal to this multiple or array. This is actually an array, and this one should leave as a single value. Okay, selected value should be date and start of the month, then closing parenthesis of filter, then the calculate. Then let's test this formula that we did, and let's bring it down here in this matrix. Okay, then let's put it right after forecast quantity and see how it goes. Okay, it's working. Let's make it full number. So as you notice that this forecast quantity is being returned here, while these numbers are not returned here. You see? Okay, the next is we need to return the values of forecast here as well, since these are also the actual forecast or the latest forecast value. So to do that, we need to put this into, okay, let's try less than and see how it goes. Then it rather return the value here. So this is not what we're after. It should be the greater, no? It's the opposite. Okay, there you go. Now you can see the value here. 54, 73, 110, and so on. Okay, let's collapse or drill up, and it should range like this. Okay, the forecast one quantity is now corrected 94, yeah, it's less than this sum up forecast quantity. How about this month of February? There should be a value here. The 42, it should return a value here. So how come? Okay, what happened is that during that those months of January, there was already a forecast quantity for the month of February, but when the February 2020 reached, there is no forecast quantity itself. So this, we need to bring this quantity over here. So whenever this is collapsed, it should return the value 42 here as well. So how to do that? We need to introduce additional formula. Then we will use if function later on. Forecast, let's call it forecast quantity 2. Then again, we need to use the calculate function. Then of course, again, we need to use the sum. Actually, we can use this one right away, like that. Forecast quantity 1 or the sum and forecast quantity. Yep. Okay, let's try this. Then, of course, before executing this whole code, you need to use the if function, quantity 3. Yes, called quantity. So, if is blank, if the value is blank of this forecast quantity 1, yeah, if this is blank, then it should return the value forecast quantity 2, else forecast quantity 1. Okay, now let's put this last formula as a return value. Okay, come on. Okay, there you go. Everything is correct. And okay, 86. Yep. So okay, seems correct. How about this total? The total that appears here is actually wrong. The order quantity is correct, but the forecast quantity total is wrong. As you notice, they are both 5087. So something is wrong here. So let's total this forecast 1 quantity and see how they result. Okay. So I manually calculate the total of this forecast 1 quantity row, and it should result 1801, not 5087. To correct this is we need to seek help from summarize function, because we need to total this forecast 1 quantity using this matrix table. So to do this, we need to add a new measure. So this time we call it forecast 2 quantity, because we have a forecast 1 quantity. Now this is forecast 2 quantity. And since we're going to sum up all these rows of forecast 1, we need to use this sum x function. Then on this table parameter, we need to create our own table hiding this matrix. So this time we need to use the summarize. So the summarize is good in making a hidden table. So the first table parameter that this summarize is asking for is, so since we're going to use this x-axis, which is the date main or the main date, we need to use the date main as well. Yep, here it is. Then the group by column name is, of course, the date main as well, and start of the month. Then the group by column name, so we stop there, we need to jump immediately on this name. So we need to call the new column name as forecast 2, for example, any name you want, because we need to recall this column name later. So as you notice that I skipped the group by column name 2, so I just go straight to this name number 1. Then expression number 1 is this forecast 1 quantity. So this is the one that should return the value, okay? Because this forecast 1 quantity is the same as this in this row of matrix. So then close parentheses of summarize. Then we need to return the value of this forecast 2. Yeah, this is the syntax of summarize and sum x when they work each other. Okay, then enter. Then let's bring down this forecast to quantity just here. Oh, now you're getting the correct number. Let's put it whole number. So everything is correct. Do you see the total quantity is now correct? 1801. Here it is, 1801. Now we don't need this forecast quantity, the old calculation, and also this forecast quantity. Okay, we need to correct this ADS or absolute difference because the absolute difference still refers the old measurement. So we need to use the forecast 150 so that it will sum up the correct absolute difference as well. Okay, as you notice, if you sum up this absolute difference, it resulted a 325. Okay, it's time to create new measure. This time is mean absolute deviation. Since we have already the absolute difference as we calculated in a manual method to Excel, the overall MAD is just the average of absolute difference of order to forecast quantity. So we will put our DAX formula under this all MAD DAX formula so that it's a bit organized, even though this is a bit cluttered, looks like a bit cluttered. Okay, let's name it MAD. Yes. Okay, since that is only an average, we use average X. And the table is based on this all selected start of the month of X-axis, which is the date main or the main date. All selected. The reason why I'm using all selected because it will return the value, the same value of MAD across this column until to the total. So date main start of the month, then okay, the expression is the absolute difference of cost and enter. Okay, then let's bring down this MAD just beneath this absolute difference, and there you go. So the ADS is calculated 23.78, and then the total should be 23.78 as well. Okay, now next is the rolling calculation of MAD depending on your preferences, let's say 6 months, 3 months, or 1 year. So we need to use a different formula. So let's add a measure. Okay, let's call this a bit longer because we can shorten it in a later part so that we can understand what's this calculation all about. Calculation, then okay, let's use var and return method here. Then okay, let's name it average ABS of difference. Then of course the all powerful calculate function. Okay, the expression is the same as the math. Huh? You can borrow or use the MAD right away, the one that we did. No need to repeat again and again. Then the filter should be the dates in period. This is the time that we need to use the dates in period. Dates in period is looking for dates, start date, number of interval, and interval. It returns the dates from the given period. So dates. The dates to be put here should be the main date of x-axis that we are putting on here in this matrix, which is the date name. Yes, it will be the start of the month. Then start date. The start date should be a single value. So we cannot use straight away the date just like this. Yeah, we need to use the maximum, then date. Okay, since we are calculating the MAD in a backward method, let's say past 6 months, past 7 months, depends. For the time being, let's put it 6 months. Then the interval is, because this is monthly, we use month here. Then enter. Then closing parenthesis of calculate. Then we can turn the value on that average absolute. Then enter. Okay. Now let's put this under this MAD. Okay, it's quite long. Yeah, let's rename it. Rename this field rolling. Okay, it's forward. So for the time being, let's call it rolling. Okay, let's check the formula. So we need to bring down the last 6 months of ADS or absolute difference. 17, yeah, 36, then 14, then 6, then 37, 179. Then the average is the 1, 2, 3, 4, 5, 6. There you go. 48.17. And there you go. 48.72. If I do this further down, 179, let's say 32, then it should result 50.67. And that's it. 50.67. Okay. Now let's go back to this monthly rolling calculation. We need to make this number dynamic whenever we wanted to adjust it in a different month. So we need to use a new parameter. So here I already created the new parameter just shown here. So the way I did this, you just go to this view modeling. Yeah, under the modeling tab, just go to this new parameter. Then just call this, let's say MAD rolling 2. Then whole number, minimum, yeah, 0. Should be 1. Maximum, you can put it 200. Then increment 1, then ensure that the add slicer to this page is checked. Then it should appear here. Okay, here it is. It's just hiding. So we will not use this one because I already created a new parameter. So we just delete this MAD rolling. Okay, so this MAD rolling new parameter is as simple as generate series. Here it is, generate series 0 to 24. And okay, now going back to this MAD, the monthly rolling calculation. So having this MAD rolling value through parameter, we're now able to replace this. Let's say MAD rolling, here it is, MAD rolling value, not this one, but this one, okay? Then let's not forget this negative sign because we are calculating the MAD in a backward manner. So 4850. Okay, the parameter is quite long, so let's separate this MAD rolling to separate variable. Then let's call this number of months. Yeah, here it is. Then let's remove and replace by number of months. There we go. Then enter. Okay. Here it is. 4856. Same. Let's put it 7 months. Okay. 45.86. So let's stretch this 1 month. 45.86. So it's correct. Okay, my friends, we have almost most of the essential measurements needed to complete our visual, such as the stock column chart, the waterfall variance chart, and populate this matrix visual so that we may able to sort out the highest and lowest mean absolute deviation of each product. So before doing that, I will reiterate that the calculation of MAD is dynamically adjusted based on this date coverage. Take a closer look and see what happens. And also in this date forecast review, if I expand it, then you will see the difference. Okay, let's trim it further and see what happens. Okay, let's expand it, then trim it further. Oh, there you are. Okay, and also the rolling MAD monthly calculation. If you want it every 3 months, it will calculate the MAD 3 months coverage date backward. So let's begin to populate this stack column chart. So this chart, click the chart, then let's bring down the main date first under this shared axis. Then the MAD is here to this line value, then MAD on the column chart. Then let's convert this into start of the month, disabling this date hierarchy, and you will see the difference. Then under this column series, we can put on this product group or item description depending on your preferences. So how to visualize each product? So we need to filter it. You can use this slicer. just choose 2 or more products, not more than maybe 10 or 20, because it's a bit messy. Then here, under this matrix visuals, we can sort out the highest and the lowest MAD. So let's put on this product group and also the market above the product group. Then the values, let's put this MAD. Then let's expand. Okay, then let's clear this selection, then sort out from highest to lowest MAD, and here it is. So let me put some comma here so that it is more readable, and I'll put only 0 decimal, so that because this is MAD anyway, so it doesn't matter. It's not a big deal using a 0 decimal. Then you can choose which product to compare. Then under this stock column chart or unstock, we can rename this column chart. The purpose of this unstock column chart is without the need to put per product. It's like the total or the overall MAD. So under the shared axis, let's put on the start of the month, convert to start of the month. Then line value is MAD as well. Then monthly rolling. So it is, even though if you choose multiple product, it will just automatically total the MAD. Okay, as for the variance, we will visualize it using the matrix located in the middle of this canvas of Powered Eye. So let's populate the XY axis first by dragging and drop this start of the month into this rows field, then the market into this columns field, then product group. Then you can continue the item description depending on start of the month. We need to disable the hierarchy, then that's it. So as for the values, we cannot use straight away the absolute difference because it always returns positive value. What we want is positive and negative values. So the variance formula is as simple as this. Variance, and the formula is as simple as ordered quantity minus the forecast to quantity. And let's not forget to multiply to -1 because we need to show excess inventory should have a positive variance. Or you can swap this forecast quantity order quantity. Reason why I did this, I just maintain a protocol formula. Then let's continue, enter, then bring down this variance into this values field, then let's put some data bars and remove the numbers here. Show bar only, then active gray. Okay, so here it is. So you can filter it and it will show the behavior of the variance. The green means positive variance. The red is negative variance. Okay, since we have a variance measurement already, we may now able to populate this waterfall chart. So this is as simple as the variance should be under the values, then the category is the start of the month. Here you go. Okay, we need to deactivate the hierarchy, then should show like this. So this is actually the combined waterfall chart data of all the products. Yeah, so if I choose or select 2 or 3 or 1, they just combine in this waterfall chart. Okay, so most of the essential setup were already tackled here in this part 1 video on setting up this Power BI to have to give a meaningful insights about the mean absolute deviation and also the variance. And also we already completed most of our important DAX calculations, especially the MAD, the correct quantity of forecast, and also the variance. On the part 2 video, we will tackle on how to integrate these MAD limits calculate into this report so that you have a better control of your forecasting or which one that needs to be prioritized. And also I will show how to use this MAD or how to calculate this MAD costing, because as you are aware, it doesn't mean that the MAD is high, the cost is also high. So there are some high cost products that have low MAD. So you can set up your goal which needs to be prioritized, the cost or depends on the quantity. Also, you've noticed there are some green and red arrows here. This represents a positive variance, and while the red represents the negative variance, so that you're able to see which one that has a excess inventory. For example, this GP08, it has a positive variance. So by right, it should show here in this waterfall chart. It has positive variance. How about this GP12? Yeah, positive variance. And the GP38 has a negative variance. It's below 0. Lastly, I will show on how to assemble this kind of chart, having a order quantity and the green represents excess quantity or excess inventory, while the orange is shortage inventory. So on the following video, I will also make some Power BI report on how to use this mean absolute percent error, mean absolute error, and the mean square error. So stay in touch, my friend. Thank you very much.